We've learned that one of the functions of currency is that it needs to be a store of value. So our money needs to be worth relatively the same amount in the future. But that isn't quite so simple in reality. Our money stores value well, but we know that inflation occurs. So money will have different values in the present versus in the future. Suppose you could have $1,000 today or $1,000 next year. Which would you choose? They might seem like the exact same amount of money, but they're actually not quite equal, and there is a right answer to this question. So the right answer to the question is that you want that $1,000 today, because a dollar today is worth more than a dollar a year from now. And there's a couple of reasons why. The first thing is you were offered $1,000. If you need the money now, you can use it now. And if you're waiting for a year to receive it, you might incur some expenses. You might need to put those onto a credit card. If you don't have the money and you end up putting that expense on a credit card, you're going to pay interest potentially. So it could cost you more if you don't have the money now. The other reason is, let's say you don't need the money right now, but if you received $1,000 today and put it into a bank, into some sort of interest earning account, you could actually have more than $1,000 at the end of 1 year. So either you save money from not having to put expenses onto credit cards and pay interest, or you can invest the money and use it to earn interest. In either case, it's worth more now than in the future. I found that a lot of my students get interest confused in terms of when are we earning interest and therefore it's good versus when are we paying interest and therefore it's bad. Because there are certain situations when you want the interest rate to be high and other situations when you want the interest rate to be low. It all depends on, are you earning interest or paying interest. So in the first situation, if you have that money now and you are depositing it into either a savings account, a certificate of deposit, maybe a bond, something that will pay you interest, you're going to earn interest from the investment. So putting the money into that account will earn you interest. If you use that $1,000 and you loan it to someone else, you also could charge them interest and you could earn that interest from the loan. So depositing money and loaning it to someone else are both ways to earn interest off of your money. Now, if you decide not to take the money now and you need the money all of a sudden, maybe your car breaks down and you have a sudden expense and you have to use it, if you ended up taking out a loan or putting it on your credit card, both of those in essence are borrowing money. And in both of those situations, you could have to pay interest. So taking out a loan personally is different than loaning someone else money. A loan that you're taking out in your name costs you money, you're paying interest. If you loan someone else money, then you're earning interest on that. And anytime you're borrowing money, you could pay interest, which could cost you more in the end than if you just took the money right away. Let's do some practice problems with interest. So you are going to loan your friend $100 and he is going to pay you back in 1 year. Assuming no inflation, you agree to a 10% interest rate, the going rate you could receive if you had simply saved the money. Now, just for the record, that's a really high interest rate for a savings account, but for the sake of our example, you're going to charge 10% interest. Why do you need to receive interest on this loan? Well, there's a couple of reasons. This can offset any penalty that you would pay if you needed the money. So if you needed the money and you have to pay interest by putting it on your credit card, you want to offset that. Also, it pays you back for the service that you have offered of loaning your friend money. And finally, it's quite possible that there will be inflation. Even though we're assuming there's no inflation, there's no way to know. And so charging a little bit of interest is a way to protect you from any inflation that might occur and can hurt the value of the money that you get paid back. What is the opportunity cost of not loaning your friend money? Well, it's the interest that you would have received. So in this case, 10% of $100 is $10. So that is the price that you would not receive if you didn't loan your friend money. And then, how much will you be repaid at the end of the year? So the way you do this math is we already figured out that 10% of $100 is $10. But he's not going to just pay you back $10. That's the interest. He needs to pay you back the principal of the loan, the $100, plus the $10 in interest. So the total that you'll be repaid is $110. So you can see two ways that these equations were set up. We have the original amount of money, $100, plus 100 times 0.1. That's finding 10% of 100. So you could also do it this way. Both of those are going to be the principal of the loan plus the amount of interest charged on that principal, which gives you $110 total. Before talking about compounding interest and how we multiply percentages over multiple years, I wanted to do just some basic tips on multiplying with percentages because a lot of people don't know how to do this or they do it in way too many steps. So I'm showing you the shortcut to how to multiply by percentages in your real life. So first of all, I hope you know that percentages can always be converted to decimals out of 100. So 20% would be 0.20 as a decimal. 5% would be 0.05 because we have 5 out of 100, and 32% would be 0.32. And so on and so on and so on. So step one is just being able to convert the percentage into the decimal. Now, when we get to multiplying, if you are adding a percentage onto something, so let's say you're going to add interest rates to a price, you're charging interest, you're paying interest, or you want to, in your real life, you want to figure out how much something will cost, you're going to have to add sales tax. So in that case, we're going to take the decimal and add it to 1. So 6% sales tax. If you have a $5 item, 6% sales tax, you're going to multiply by 1.06. Now, you've probably done 2 steps where you do the price times 0.06 and then you add that to the price. Now, that works, but it's 2 steps. In this case, you just take the price times 1.06 and it's already adding on the 6% as opposed to finding what 6% is and then adding it. For interest, if you are paying 20% interest, you're going to multiply the number times we're adding it. So it's 1.2 or 1.20. It's the same thing. But the idea is it's 20% interest that you're adding. So it's 1 plus. So $100 times 1.20 will give us 20% interest on 100 as opposed to finding 20% and then adding it in. If you are subtracting a percentage, I do this most often. If you're shopping and you see 35% off, you could figure out what 35% is and then subtract it from the price. But again, that's 2 steps, and our entire point is to do this in 1. So you take the decimal and subtract it from 1. So 30% off, 30% as decimal is 0.3. And 1 minus 0.3 is 0.7. So for 30% off, if you multiply the price times 0.7, you've automatically done in 1 step that 30% savings. 15% off, 15 is 0.185. 1 minus 0.185, 1 minus 0.15, I'm skipping ahead, is 0.85. So 15%, if you just multiply times 0.85, it'll tell you the amount you have to pay. So if we're adding a percentage, it's going to be 1 plus that decimal. If you're subtracting a percentage, it's 1 minus that decimal. So I hope that this makes you understand why the equations are the way they are on the next slide, but also just see a shortcut that you can use in real life. So we're back to our practice problem where you've loaned your friend $100 at 10% interest, but now the friend wants this loan for 2 years instead of 1. Interest rates tend to be compounding, which means that the person is not going to owe you 10% for 1 year and 10% for the next year, because at the end of the first year, that $100 has become $110. And then we take 10% of that slightly bigger number. That's what compounding means. It means the number is growing. So how do we set up this equation? We have the principal of the loan, $100. And remember, we're adding interest, and the interest is 10%. So we have 1.10. But because this is 2 years, we're doing it twice. And that will give you $121. You could also look at it in terms of, all right, after year 1, it's $110, and then adding on 10% of that, it'll get you the same amount. But I just wanted you to see that when you're setting up these equations, we have the principal of the loan. We have the amount of interest, and then the amount of years. So after 1 year, this is good enough. After 2 years, we're going to start getting exponents. And that's why this works the way that it does. Okay, so to generalize what's happening, your friend as a borrower must pay you $21 to compensate you for the fact that he has your $100 for a period of 2 years. So he's paying back the $100 principal plus $21 in interest because the interest compounded. You've learned that money is worth more now than in the future, and this becomes useful to real-life decision-making when we're looking at costs and benefits. So the first idea is that costs now hurt more than costs in the future. So we're looking at this question at the bottom. Paying a fine. Do you want to pay a fine now or in 1 year? So let's say you owe $500 and you could pay it tomorrow, or you could pay it in 1 year, no penalty to waiting. When should you pay it? You should pay it in 1 year because the money is worth more to you now. You could use that $500, you could put it into an account that could earn you interest. And then in 1 year, when you have to pay that fine, you have more money than you started with. Also, if you need the money, in the meantime, you want to be able to use it now, right? And not pay any interest on that, and then pay the fine later. In real life, this happens. Things like car tax bills. Normally, your car tax is due in October, but they send you the bill in August. So you could write the check right away, especially if you're the type that will forget to pay the bill, that sort of thing. But if you can remember, if you're organized, you could keep that money in your bank for 3 more months, earn a little bit of money of interest on that money, and then when you pay that car tax bill that you have to pay anyway, you've used the money in the meantime. Benefits now are worth more than benefits later. So here, if you're going to receive a bonus, do you want that now or in 1 year? You want that now. Same idea that you want to be able to use the money now. You can make money with the money by loaning it to someone or putting it into an account that can earn interest. If you need to spend the money, you have it now as opposed to waiting and potentially having to borrow the money yourself. So, present values are the idea of how much is the money worth right now. We're going to talk about future values and present values. How much is it worth now? How much will this money be worth in 10 years, in 15 years, in 20 years? We're always going to look at the present value to determine whether or not you should do that decision. You should make that choice. Should your business finance that project? We want to look at, okay, if it cost my business $20,000, what is that worth now? What if I decide to do this enhancement and spend the $20,000 years from now? What would it be worth to me as well? So we're going to have to figure out present values and future values to make these decisions. The time value of money is the amount of money one would need to receive today to equal a certain sum in the future. We're going to use present values and future values to calculate this. If you need to save $80,000 for college, and so you know the amount of money that you need in the future, and you know the amount of time that you have before that occurs, this can tell you how much money do you need right now at current levels of interest rates to reach that sum of money in the future. We're going to start talking about present value and future value of money. Present value is the value of the money now, today, present value, and that gets abbreviated to PV in all of these equations. The value of the money 1 year from now will be in the future, and so future value is FV. And then finally, R will stand for the interest rate as a decimal. So looking at this equation, it makes sense because we're talking about the money now, present value, and the whole point of taking the money now is to earn interest on it. So we're going to be adding interest. Remember how we're adding decimals? It's going to be the decimal added to 1 will help us add it, and that will give us the future value. So in this example, the future value of $100 at 20% interest is $120. What's important to realize is that at the beginning of these notes, we kept saying that the present value is bigger, take the money now, it's worth more now. That was true when the present value and the future value were the same. Do you want $100 now or do you want $100 in the future? Well, then the answer is take it now. But the whole point of taking it now is to earn interest on it and make it into a bigger number in the future. So when you're earning interest, the future value will always give you a bigger number than the present value. And you can see here that $100 now has the potential to become $120 if you're earning 20% interest, and that's why you wanted to take the money now, because $120 in the future is a lot more than $100 in the future. The future value on the previous slide is gained through earning interest, and you can earn interest through multiple avenues. You can earn that interest through saving it in an interest earning account, or you can lend the money to a friend and charge them interest and earn the future value that way. We can also rearrange the same equation to solve for the present value. Because the future value is bigger, we're going to take the future value and divide it by that additional interest to see, okay, if I have this bigger amount in the future, if my goal is to get to this amount in the future, and this is the current amount of interest that's possible, how much do I need now in the present to get there? So in our practice problem, $200 received a year from now, so that means the future value is 200. It's worth blank in today's dollars if the interest rate was 10%. If the interest rate is 10%, we're going to be dividing by 1.5. 0.1. Because we're adding 1 to the interest rate as a decimal, 10% will become 0.1. So 200, and go ahead and use your calculator just to see how this works out for us. 200 divided by 1.1, it's going to give you a number where the decimal point keeps on going. So we have 181 point, and my question to you is, how many decimal points do you think we should do? Well, this is money, and with money we always do 2 decimal points, so let's round it. So instead of 818, we're going to round that to 82. So the point of this is that $181.82, if you're able to earn 10% on that money, in 1 year will have a future value of $200. In case you were wondering why we didn't have these equations in their rectangles yet, it's because these equations weren't quite finished. There's one more variable that we have to add, and that is time. We've been talking about 1 year and only 1 year, a future value of 1 year, but a lot of decisions are based on much longer terms than that. Loans can be for longer than 1 year. If you're saving up for a major expense, you're going to be saving up for longer than 1 year. So we saw, if you're calculating interest for your friend and it was 2 years, remember how we did that little subscript of 2, the exponent of 2? Superscript of 2. So the idea is, when we were doing interest, it was 1 plus the interest rate raised to the number of years of the loan. So in this case, the equations are the same. Future value equals present value times 1 plus r raised to the t. T is an exponent and is the number of years. Or, for the present value, it's future value divided by 1 plus the interest rate raised to t, the number of years, the time of the loan. So if we're setting this up, the present value, we would have $100. If it's 5% interest, this would be times 1.05. And if it's 3 years, that would be raised up to 3. So that's how you fill in these numbers with the information that you have. Economic decisions made by households or firms often involve dollars spent or received at different time periods. So we can use this whole concept of future value and present value to figure out, should we commit to a project today when benefits may not be enjoyed for years to come? So if I'm looking at it in terms of, I have $500 right now, I could put it into this account and receive 5% interest. I could loan it to this person and receive 7% interest. I could invest it into a college fund. You're kind of comparing different options to determine, if the present value is this amount, what could I get in the future? People also do this backwards, where they look at, okay, I need this much money in the future. What do I need to set aside now at current levels of interest in order to get to that amount in the future when I need the money? What if you could invest $10,000 now and receive a guaranteed $20,000 after inflation? So here we have different dollar amounts for our present value and our future value. We know that current interest rates are 8%. So is it a good deal? Should we invest our $10,000 and receive $20,000? What if we had to wait 10 years? So we can use either one of our equations, the future value equation or the present value equation, to answer the question. So what is the present value of the money that we have? It's $10,000. We got that from the question. The future value that we are promised is what amount? $20,000. The interest rate as a decimal, so 8% as a decimal becomes 0.08, and the time that we are having to wait is 10 years. All right, so first of all, let's compare our options. So instead of taking this deal where I'm going to invest $10,000 and I'll receive $20,000, what if I invested the $10,000 myself and I earned the current 8% interest? So in that case, I'm seeing what is the future value of that money. So future value equation, the $10,000 is the present value times 1 plus 0.08 raised to 10 because that's the number of years. So if we invested the $10,000 ourselves, 10 years later, after 8% interest, we would earn $21,589.25. So is that better or worse than if we took the deal? That's more money. 21,000 is more than 20,000. So that's telling us that we should take the $10,000 and invest it ourselves. We can make more money. Let's try the other equation. So we know the future value is $20,000. And I can look at it 8% interest in 10 years to see, well, how much money do I need to invest now, present value, to earn $20,000 in 10 years? I actually only need to invest $9,000, $9,263.87 to be clear. But the point is, if I wanted $20,000, I actually could spend less at the beginning than $10,000 and still get to the $20,000. So both equations, are they telling us to take the deal? No. Future value is telling us if I wanted to spend $10,000 now, I could earn more than $20,000 in the future. Present value equation is telling us if I needed $20,000 in the future, I could spend less than $10,000 now to get there. So both of these are saying you don't need to actually use both equations to figure this out, but this is a good way for us to use these things to figure out what is our earning potential in the future, how much money do I need to invest now to get to my goals in the future. Now we have another problem where if your grandma said to you, you could receive $5,000 when you graduate from college in 4 years, or $4,000 now, which is the better deal economically? In that case, we know the present value, we know the future value, we know the length of time. The variable here is the interest rate, and whether or not it's a good deal really depends on how much money you could earn in interest on your own. So in all of these situations, we're going to use the same equation. You have the present value, 4,000. You have the years, 4. So use the future value equation for all three of these. But all you're doing is changing the interest rate. So go ahead, pause the video, calculate all three of these numerically, do the math. Remember to round to 2 decimal places because, again, it's money, and that's how many places we round. So go ahead and plug that in, and then we'll come back, check your answers, and see which we should take, the 4,000 now or the 5,000 later. All right, so A, calculate the future value in 4 years of $4,000 if the interest rate is 3%. So in that case, if you're only able to earn 3% interest, the maximum that you can earn from that money in 4 years is $4,502.04. So in that case, are you better off taking the $4,000 and investing it yourself, or waiting 4 years and taking the $5,000 from your grandma? In situation A, you should take the $5,000 in 4 years because you can see that at a low interest rate of 3%, $5,000 in the future is worth more than the $4,000 today. B, if interest rate is 5%, we're going to be earning a little bit more, $4,862.03, but that's still less than $5,000. So in that case, yet again, we should wait 4 years, take the $5,000. That has a higher value than investing the money ourselves. Now, what if we could earn the biggest interest rate here, 10%? Well, then you have the ability to earn $5,856.40 on your own. So in that case, that's definitely more money than the $5,000 your grandma is offering. So take the money now, the $4,000 now, invest it yourself, and you can earn more at the end of that 4-year term.